The question asks for the first and the second derivative of y when y is implicitly defines a function of x through this equation. So first thing you have to see right away, you don't need to solve it for y. Don't make that mistake. Well, sometimes it will work, but don't make that mistake. You don't need to make it explicitly defined. You can use implicit differentiation. And find y prime. How does implicit differentiation work? Always start with differentiating the equation with respect to y. Okay. Derivative of x squared is 2x. Derivative of 6xy, this is product rule. Derivative of 6x is 6 times second one, plus the first one, 6x. The derivative of y, while you're doing the implicit differentiation, wherever you get to the derivative of y, you just write y prime. We will need it in the next step. Minus 2y squared. This is generalized power rule or chain rule plus power rule. It will be 2y prime, y to the power 1 less. And the derivative of 3, any constant, is 0. So this is 2x plus 6y plus 6xy prime minus 4y prime y equals to 0. When you do this step, differentiate, you will find an equation for y prime. Solve that equation for y prime, meaning what? Keep the terms which contains y prime on one side and send everything else to the other side. So it was 6xy prime minus 4y prime y equals to minus 2x minus 6y. And then factor out y prime there. The first term will give me 6x. And the second term will give me 4y. And then, well, as we do solve, like, what is 2x equal to 1? Divide the coefficient of x to the other side. You get that. This way, basically, you found, yes. This way you find y prime, and we use implicit differentiation. Why implicit differentiation? Always remember, because the equation, or y, was not explicitly defined. We had to do something. When it comes to implicit differentiation or functions implicitly defined, finding the first derivative is these steps that you have to take. But then for the second derivative, what you have to know, this is very important, is that you don't need to do implicit differentiation again. What you need to do is look at the equation which gives you y prime. And we know that the first derivative of y prime is y double prime, or the second derivative, yes? So this being said, y double prime would be the derivative of this expression. I have to differentiate now. Okay. Derivative of the numerator, this will give me minus 2 minus, I'm differentiating 6y. What I need to put there is y prime. Derivative of numerator times the denominator minus the derivative, the numerator itself, times the derivative of denominator, which is 6 minus 4y prime. and then the denominator squared. Now, I am done. I found the first, the second derivative, but what you have to notice is that there are y primes here. What did I do here?
You forgot 6.
Yes, you're right. Thank you. Okay. It doesn't like to be read. What I will do it. The rest is good, yes? Okay, so I see two y primes and I don't like those y primes, meaning that I have to replace it by what I have found in the first step. So y double prime is going to be -2 minus 6 times the whole thing there. Six minus 4y minus 2x minus 6y times 6 minus 4 times minus 2x minus 6y over 6x minus 4y, and then divided by 6x minus 4y squared. That's finding the second derivative for implicitly defined function may seem strange, but it will be straightforward if you just consider that the second derivative is the first derivative of f prime.